In this lesson, we're going to examine how changing flux is caused by the area and the B field angle changing. So what we're looking at in this problem is going to be a single rotating coil, this rectangular coil that I have shown here. We're going to say is rotating around this axis. We are going to focus our analysis on that highlighted region and the point P. So please get in your notes that we're going to follow this point P and look at I induced in the coil relative to is I induced going to flow into P or away from P? Okay. So in this problem, B induced is constant, or B external is constant. It will not change in the entire problem. It's coming in the positive x direction only. Our perspective is out here, so it's coming straight at us. We are looking at the full area, right? The n hat vector is coming straight at us. And I'm going to clean this up in a moment, but we're looking at the full area of the loop, and it's the point P is about to rotate away from us. So that's what we're seeing here. The point P is now rotated away from us. The external B field is the same. And notice what is going on here is we are losing, what we are seeing is magnetic flux through the area of the coil decrease coming at us. So I want you to think about Lenz's law and the fact that nature is going to fight the effect that is causing the change in flux. So nature is going to try to fight the fact that we're losing B field coming at us. So I want you to think about whether I induced is going to go into the point P or is it going to go away from the point P, right? So is it going to go toward P or is it going to go away from the point P? So think about that for a second. Pause the video, and when you unpause, we'll talk about what actually happens for this first one, and hopefully you'll begin to see how this game is going to be played. So pause the video and think about whether it's going into P or away from P. All right, hopefully you rationalized your answer, and let's see what actually happens. All right, so we were losing B field coming at us, as we said, right? So losing B field coming at us, which means nature wants to make B field coming at us to fight that loss. So what's actually going on here is that, yes, I induced is going to go into the point P, so make sure you get that into your notes. Now, technically, the full B induced is going to be perpendicular to the plane up here, so I didn't put it in right away, but that's why I have the B induced in the x direction, right, is what I'm thinking of in terms of my Lenz's law analysis. I need some B field being generated coming at us. So when we go from 90 degrees to 180, so it's going to rotate flat through that whole 90-degree rotation, the current is going to be flowing into the point P. So hopefully, again, you'll begin to see how this game is being played. So we're going to pick up our analysis with the point P now flat. So we're saying it's down at 180 degrees. The whole coil is flattened out. So there is no flux going through the coil. Now, as the coil rotates, we are going to begin to see magnetic flux coming at us. So we're going to, again, come over here and pick up our analysis where the point P is rotated down from that 180. We go, now the change is a change of state from no flux, right? So here we have no flux to here we now have flux because the B field is coming at us, and nature wants to fight that change. It wants to remain at no flux. So it wants to fight the change of flux coming towards us. So think about for a second how the current has to flow, again, either in the direction of P, towards P, or away from P, in order to fight that flux change that we're seeing coming at us. Okay, hopefully you've made your guess, and let's see what's going to happen. All right, so when we begin to see flux coming at us, right? Remember, nature wanted to keep it with no flux. So it's going to fight that change by making flux in the opposite direction, but that doesn't change the direction of the current. So the current is still going to flow in this sense toward P in that highlighted section. Again, technically making B field be induced like this, but we need the be induced in the x direction this way because it's fighting that increase in flux coming at us. I know this is a little tricky in terms of you have to really step back and think about it. But now the point P is rotated down here, and our new initial state that we're going to analyze is the point P is down here. So I guess I lost my highlighted section here, but the highlighted section is still down here at the bottom. So as the point P begins to rotate up, we are now losing B field coming at us. So remember, B external is coming at us. And we're now losing B field coming at us. So think about how the current has to flow relative to the point P and the loop, kind of clockwise or counterclockwise, to make B field coming at us to fight the loss of B field that we're seeing when we had full flux here coming at us. So full flux is our initial condition, and here we're losing flux. So nature wants to make flux coming at us. So what do we get? Well, now we get a reversal. So the current is, at this point in time, no longer flowing toward the point P, right? It has to flow away from the point P in order to make some component of the B field coming at us. Okay? So again, the full B induced is up here, and that's B induced in the x direction, but basically the current has now flipped directions. So we're going to do one last rotation, so hopefully you're seeing how this game was played. We're starting with nature in its initial point being no flux. And now as the point P rotates up, we're beginning to see flux come at us. So nature wants to fight seeing flux come at us. So how is I induced being made to want to fight that increased flux coming at us? And hopefully you have guessed correctly. Boom. That yes, it still is flowing away from the point P because we go from no flux over here to seeing flux. Nature says, nope, I don't like that. I don't want you seeing flux. I don't like that change. So I'm going to keep the current going away from the point P for the final 90-degree turn. So we're going to look at the mathematics of this in detail, but I wanted conceptually for you to see what you would see if you were this actual person looking at the flux coming at you, to understand why during this first 180 degrees of the rotation from 90 to 270, right? We get the current flowing in one direction. And then for the final 180 degrees, we get the current flowing in the other direction. that just based on Lenz's law and the concept involved, that it makes sense. And in our next lesson, we'll look at the mathematics of it.